Alright, so I'm gonna kind of handle this like I did with the n-body simulation recording. Just kind of going through what I did, kind of why I did it. And so I guess to start out with globals, just basically the only things I'm really passing through all of it are the window and the screen size. Yeah, this the level struct I use just to represent better for readability purposes what's going on with loading levels. So I was having some issues with assets, but here's all the assets I'm using. And then I kind of load up the sounds to this level advancement. Right now I only have 11 levels in the game. Might add more as time goes on and improve the general adding system. You got, and then here the main sprites, just some low quality but hand generated assets. And yeah, this is actually what I went with for this entire project. Just leftover but useful functions from the past, the n-body simulation, with respect to just making it work cleanly across most devices. Then as far as how I load my levels, I basically just assign some set orientation of flings to the current flings array to render, which will then be rendered in the render method describing exactly like how much space we have, the positions, and then like really just the I guess looking through this, clearing it all, setting what positions I need to use, where to start. Then first off rendering the cells so that they're in the backmost portion of the I guess setup. Then going through and rendering the flings, then going through and conditionally rendering a little crosshair to select, and the overall menu at the very end. That way that, I guess for layering purposes, when a fling flings off, it kind of hidden by the menu as you see in the game. And going through and looking at how I set up the game, basically just going through and setting up for some basic size initial flings. They aren't really used, but it does give a good size to start out with, and then just really specifying it. I've kept it as square to try and maintain fine enough looking sprites that aren't compressed too much, as I just basically load the flings to a single cell that can be stretched out. I'm trying to avoid that though. That's what I did. And then I have a loop, a separate startup loop and startup render to handle cases of like the initial menu. Basically just throwing up, clearing everything to make it a pure black background, loading up the menu sprites, the selector, and then some special selection that's basically just saying, hey, this isn't exactly evenly spaced to the title cards, so handling that while also giving me the information to select whether I need to go into solving mode, or rather solving mode or level mode, or if I just need to exit altogether. And then with this, every frame you just re-render stuff. The normalized dimensions function, just basically something to, with flings passed in, make sure they're set such that they start at 0, 0 and go to, I don't know, whatever, just offset. That way you don't have negatives messing up the rendering. Then moving on, so this is a sort of, I guess, specialized thing that helps me process moves and get the next move from when I'm actually like drawing instead of calling the actual fling methods. But yeah, but it's fling. Now your fling left. I guess I'll quickly run through it since I've gone through the setup part of the GUI. So basically, just a method to make sure to get what direction two flings are in, and make sure that they can be flung to each other, returning basically a none enum if they cannot. And just an overall method to get all potential moves, barring some, I guess, overlap. Then recursive methods to handle that, making sure to record whether they are recursive or not, such that the Fling solver itself is aware of that. For right, left, down, and up. Then the move handler just to kind of select which method to use. I use a vector throughout all of this because I wanted to explore C++ data types and data structures because they're so cool, I guess. I mean, you can add and remove stuff to them. They can be used. I don't know. Then just the, I guess, overall fling controller method, making sure to record to references. I love these guys because they just kind of let you control whether you're modifying a I guess copy of the variable in a way, or if you're actually modifying a shared value for the variable. For lack of a better word, I like the idea that you can just kind of mess with done in this case, and then everything with the reference for done knows it's done. It's so cool. It's kind of like Java references, but I don't hate myself. And then yeah, just fling the solver to kind of control it all. I give you the moves or an empty move vector if it's if it can't solve it, and then find fling and find index. These guys are for just solving in the GUI, helpful functions for me to call as I need. Then just quickly going back to the GUI, yep, your main loop, which it's long, it's very long. I'm not super proud of how this went, but this is where I ended up handling my inputs from the keyboard, so it just slowly crept scope-wise, but either way, here you just have the width and height for further use within the method. Just some flags for solving and processing's sake. That way I can, alongside loading levels initially, and just that processing, know when I'm done and if I should print or any other debug tools present. Obviously, people won't have the code when playing the game, so that doesn't really matter for anybody, but those debugging and developing it. And for this, it's basically just something to kind of A, allow you to progress, and B, play some voice lines I decided to record for this. Just some fun little things, some touches to the game. And for the solving, I decided to use kind of like a batch-based system. It's basically just a vector of vectors and moves to process, split up by whether they're recursive or not, to then feed into the actual move move processor function I use. And like if there's moves to be done, that's where that move processor is called. For key events, just hey, exit. I handle things based on a key up system, such that only after you release a key, stuff happens. You move around a cursor or actually do the flinging if it's selected. This for levels allows you to go back to the start, kind of a reset button. Yeah, a lot of the levels, at least later on, get to be at least somewhat harder I would argue they get to be quite a bit harder. Then these are just some remove flings if you're in the testing, I guess kind of fling mode. And then return, just select something or set the index. Basically just, this is how you interact with the game. Level select, return to main menu, zoom in and out. This was something I decided to add such that there's kind of a degree of control and size you can use within the free play Fling Solver interaction. And then this is the solving with a little fun little bloop if you can't actually solve it. The move processor method where stuff gets done. Basically, it's long, just like the main loop, so beautiful. This is where I decide to process step by step each frame, the position of a move, flinging it to another move where I have a speed value set to 25 because I find that works best, giving you visuals as to what's happening while also, I guess, really allowing you to not bore the player to tears. And then progress such that for the final fling, you actually know when it's done. For the way I handle the final fling is basically just, hey, make it go off grid completely, spanning the entire thing plus some, and after it's gone off grid, I just remove the fling and play a fun little sound effect. Honestly, I just kind of have fun with those little touches. Then the levels method, it's not great. Basically, I just went through, looked up some cool levels online alongside some stuff I thought of, and then said, hey, I'm gonna add them, fling by fling. Probably not the best idea, but that's where we are. And then main, just calling some stuff, setting up OpenGL, SDL, God bless SDL for Mixer especially, alongside loading images, and just the visual display, and then also getting a glue setup, and then closing all required, I guess, setups. I just want to touch on this for a bit. This gave me trouble. The mix opening audio between what frequency to use, and apparently the batch, how big, or I guess like how big of the batch and buffer stuff, that matters a lot for latency. So it turns out 1024 is a fine enough value, but 1 is a terrible value to use because it causes cracking and other bad things for slower PCs. I would never have guessed it, but apparently that's the case. Then for this entire project, I used a lot of helper methods. So I will go through and just kind of, these were all developed with the help of help and advice of tutorials out there. I was looking into proper, I guess, strategies for game development alongside how best to load textures. So like the resource manager, basically it was suggested to use shader and texture as a class. Then you just build your shaders and your textures, pass them to things like the sprite manager and the resource manager, allowing easy ways to load and remove these shaders and textures as needed, making cleanup not too terrible and generally keeping the development process easier. I mean, like going through shader, it's got just about everything I would need, allowing you to bind uniforms as fairly easily, just passing in information and what you call them, and then that just lets you bind the uniform or even attach attributes. Also helpful. I love this for shader development. Turns out it's very useful, especially for for the texture process, which it works. Apparently, there's this STB image, this great image loader that you can include into your projects. I was recommended to use. It lets you it's just kind of load your images and specify how they're wrapping, generating, like the nearest neighbors. Very helpful. That's how the pixel art is able to expand across such, I guess, like any size without weird blurring or any issues, as it just binds to the nearest pixel. Or at least that's how I believe it works. And then I guess going through sprite render, you set up a basically the textures and positions as a square. Everything is rendered as a square in that. So, and then you just overlay textures on top of the squares. So that was how I was suggested to do it. A lot better than my initial idea of making all things circles and then trying to load textures on them, which would lead to, from what I believe, kind of awkward texture setups, as it would be like trying to bind a lot of textures there. But so then you pass in the information to the shaders, so like texture coordinates and actual position coordinates. Pass the texture coordinates to the fragment shader. Use position coordinates and the vertex shader. The mixture of those lets you render the texture. Going further through texture, or the I guess sprite rendering process, you bind the data. You send the data into the shaders through the attribute pointers, binding them and unbinding them, in this case, sending them to their initial values, and then inside of it, the frame-by-frame drawing sprite, pass information in and bind the buffer, and then tell it to draw alongside rebinding the vertex array object, this great texture and position coordinate block, after doing some data processing based on size, rotation, and position, and then finally drawing it. It took me a while to figure out why. Apparently this is still not good practice to be feeding information into the buffer every single frame like this, and then using the vertex array object as well. But I could not get it for the life of me to work outside of this. So the duct tape solution was the play. And no debugging could get me to the point where it would actually work. So that's where we ended up. And then Makefile also kind of adapted from a tutorial, and then lots of fun Googling and ChatGPT interaction to figure out how to get it to a exe through MinGW64. And this Makefile was basically just adapted to that, using all the fun Windows versions of OpenGL related packages and imports alongside compilers. Regardless, this lets me get a clean main.exe from my main code, and that alongside the DLLs lets you, in theory, download it from itch.io and play it on most Windows devices. So that was that's kind of the development process of this entire project. It took me a very, very hot minute, but honestly I had a lot of fun making it. We got to do a mixture of game development and actually solving Fling in C++, learning more C++ from then the embody simulation, and getting to play around with references and vectors. Hopefully, in future projects or even just regular coding, I can learn more about auto, other data structures, more use of map, that type of thing. But thank you for listening, and I'll cut it off here.